Hi, everyone. Welcome to Office Hours, the evening edition. If you're watching on YouTube, you see a little button down below or a little link, and you can click on it. You'll end up in Zoom. From there, you can hit another link down below, and you'll end up in Makana, and that's where you can actually ask questions and chat with everyone else. Today, if you're listening, we're really focused heavily on live streaming, the infrastructure, the future. We have some incredible guests here, so really focus your questions on live streaming. We'll be jumping into that in just a second. And yeah, this is the evening session. We do this every morning typically, but we do one evening. So we have some folks that just can't make it in the morning, and so we're shifting it up on Mondays, only Mondays. So so it's good to see all of you here. I have some old friends that were kind enough to join us. Andy Beach and Colleen Henry are here to talk to us about live streaming or to answer some of our questions. Andy, do you want to? We'll start with Andy. Do you want to tell people what you do, what you've been doing?
Sure. What do I do? Oh man, that is a tough question.
It's so complicated.
I try and make video work. That's probably the biggest one. What do I do? So I work at Microsoft these days, working on sort of both the live and VOD media infrastructure for some of our big customers. But for 25 years now, I've been in the streaming media business. I started as a producer of streaming media before there was such really a thing. And then somewhere around 2006, I started building encoders for a living and sort of moved to that side of the world, and haven't looked back. I have enjoyed trying to figure out how to continually make this complicated mess easier for everybody to work on.
Has it gotten any easier? It seems to be going the other direction.
It's probably going the other direction, but only in so much as that we just keep throwing more at it. Like it got easier because we were just looking at a very narrow slice of things, and now we're throwing 4K and all this other stuff at it, and it just got more complicated. And I think of it as job security.
Yeah, absolutely. Colleen, do you want to give people a little of your background?
Yeah, so I'm an engineer at Facebook now, working in Facebook Reality Labs in sort of the Oculus area. Been at Facebook for 7.5 years. Before that, Google startups, and before that, I worked at Twit, which is where I met Alex, because he was on MacBreak Weekly, and that's where I met Ray, who is my favorite co-host. I think we did maybe 2 shows together, but they were 2 of my favorite shows because I got to ask whatever kind of questions I wanted, and I got real answers. And I'm like, I want to do that again. It's like Wikipedia, but better. And then I left to go to Google. My career since then was all sort of streaming on demand, high quality movies, live, ultra low latency live, whatever. You can see behind me some of my collection of encoders, some of which are ridiculously expensive, and I don't know why I have them, and some of them that I helped design, like the Clearcaster and stuff like that at Facebook. Yeah, so Alex has always been not just a good friend, but a mentor, and as has Andy, although more on the Applejack mentorship side. I didn't know I liked it that much until I tried his. And then I have Kaylin, who's my former intern, and now I'm sort of the middle generation. She's the new generation of video engineer, and so I built encoders after Andy mentored me, and now who knows what she's going to do. Although she's working with me on my open source project, which is called Streamline, which is a open source project that teaches you how to build end-to-end hardware, software, infrastructure on AWS, player, everything in 20 minutes for your own hardware, live, well, the entire live streaming system, including the hardware. It just explains how it all works. And Kaylin's helping me on Streamline too.
You know, one thing that I thought of while we've been doing things as a group together, workshopping things on Saturdays. I think we might have to see if Colleen will come in and workshop Streamline with us at some point. That might be kind of fun. Before we get into the questions, what do you guys think about when you're looking at the big trends that are kind of coming our way in the land of live streaming? What do you think is right around the corner or off a little bit in the distance? What are you paying a lot of attention to, Andy?
Ooh. When I'm thinking about like operational things, it's like how do we make it even more lower latent video? Like that tends to be the big one. But when I'm thinking about the next step before we sort of operationalize it, it's how can we get more data out of the feed in real time to feed into the larger ecosystem to do other stuff later. So that's sort of like the science lab project part that I'm working on right now. It's like the metadata and the stuff we can pull out through compute vision and other ways.
Colleen?
So I would say the dialable latency, being able to control things from the perspective of how interactive do you need to be. So like right now we're talking in as low latency as we can possibly do because it's video chat, and then ultra low latency would be if the audience in the chat room wants to have high quality at scale, but in an interactive way where they can respond, but they don't need it to be, sub 100 millisecond. But then if you're watching Netflix, that stuff has already been produced. You can have higher quality and trade off there. But the way to get that, I think, is actually by no longer considering the codecs and the protocols to be independent of each other as far as abstraction layers go, and actually start looking at it in a more intelligent way where you're actually like, all right, what am I trying to do? These things are, if they work together, you can actually do way better stuff than has been traditionally done. So for example, you can deliver AV1 or VP9 to an iOS device on web, even though it doesn't technically support the codec. And then if you're doing that, you can build at the same time anything you want from the protocol. And then on top of that, now wait a second, if you're actually trying to do ultra low latency, maybe you want to add in things like layers, so you can have lossy channels and non-lossy channels or whatever. And so I think it's going to be making better versions of the stuff that we already know and love that actually works. Right? You ever want to hop on video chat with someone and they're on a mobile device and you're just like, just stop, right? Making that work, that's where I think things need to go. I don't think it's the new wacky stuff as much as making anything work when people want to use it, making it a utility.
Right. And that kind of jumps into one of the first questions from Jonas Tatel. A lot of his got voted up a lot in Mukana. There's a couple that are kind of connected to each other. One is, what do you think is the best protocol for a show in general? Like, what's your opinion? And then also, what do you think is the protocol of the future? Do you have any strong opinion, Andy? Or
okay.
Yeah, go ahead. Go ahead, Colleen.
Oh, I always have opinions. That's the problem.
What is your opinion? So the best right now and the best one in the future, maybe they're the same.
So if the question is to do a show, I can either talk at a higher level, which is define what you mean by do a show. Are we talking about the person who's interacting? Are we talking about contribution one way where you have multiple cameras on site and you can afford, a half second if it's awesome quality and you're switching it back? Like, let's say you're like, because I think MLB, right? They have multiple robotic cameras and they switch them remotely, and the latency needs to be low enough, but it doesn't have to be like interactive latency. Now, if you're talking back and forth like we are now, you can't be tripping over each other. So you need the round trip latency to be super low. And then on top of that, if you have the audience, they need to be scalable and high quality, but they need to be responding in the chat room in a way where that conversation can still be kind of, not disjointed, but they can take, 2.5 seconds or something like that, which is a lot of time that you can use to actually compress things better and make it more affordable. And so you can afford to give it away for free, like, Twitch or YouTube or Facebook Live or whatever, right? And so if you mean any of those, I can speak to any of those, or I can speak to how you can get rid of the need to separate those.
Go ahead. And how do you get rid of the need to separate them?
Eventually, you need to create a dialable latency protocol where you can have the ability to set relative to your use case. You need something that is WAN safe, right? So it needs to be able to recover from loss if you have dialed that one protocol to, all right, I want it to be higher quality, but I'll give you a half second or more, right? You need to be able to do reliable UDP kind of things where on the application layer, you can actually control all that, because if you're using the TCP part of the stack, you're really relying on the OS to do too much of it. So you don't actually have the control that you need. You need again, the codec and the protocol to work together, because if you want to dial it all the way down, you need to be able to assume there's going to be no time for retransmission then, right? So you need to be able to have lossy channels where you have a base layer and layered codecs, and like SVC used to be for H.264. So a good example of something radical like that. Oh, and it has to be scalable. That's the other thing, right? Because you can't, it needs to be CDN friendly, cacheable. You know, you can't spend a bajillion dollars. Remember back in the day, Andy, like RTMP, quote unquote CDNs, right? Where people like Akamai and everyone else would charge a bajillion dollars trying to give you a, you know, CDN that was a quote unquote video CDN. They all did the most that they could to shut all of that down as fast as possible, right? So I think Google Quick, which is basically, that was their proposal for HTTP 3.0, but now it's, well, I don't know what they're going to call it. It's built on top of Speedy, but it'll probably be the next HTTP anyway. I think that's the basis that's going to make this all work. Maybe web transport, web codecs, WebAssembly. Yeah, if you can get all of those things working together, then really your one trade-off that the person doing the implementation for whatever their application is needs to do is say, I would rather have lower quality at lower latency, or I'd rather have higher reliability and higher quality at higher latency. So that could be the same protocol doing all of that. But again, it has to have all of those, and all the protocols that you know now have made some sacrifice because of limitations in APIs and traditional technologies. You can't do them all. So you have to, for example, have like WebRTC for your video chat, and then you have to terminate that, transcode it into, you know, your higher quality, more compressed, higher latency thing, package it up for HTTP delivery, and throw it on a CDN. So if you want to have everything, you have to solve all of those things simultaneously, and then give somebody a knob.
Andy, what are you focused on as you think about protocols for today and tomorrow?
It's very similar to what Colleen's talking about. A lot of the, when we're talking about sort of the mix down part of production, the things that are going into it remotely, we're trying to use WebRTC as much as possible so that we have everybody on something that's fairly low latent and friendly for back and forth chatter and talk, so that you can get that experience. And then when we're talking about things that are then packaged up for consumer delivery, it's you know, in a perfect world, we're sort of taking the model of low latency Dash as much as possible, and NHLS low latency as well. But Dash is sort of the model that we're looking at for how quickly we can get it out to the end user and get that experience. The thing that customers, whenever we're talking to them, always come back to is they want to make sure that Twitter isn't beating them to the punch when they're talking about a sporting event or an event that we're all watching in real time for that thing. And so that Dash has been the way that we're doing that today, and sort of adhering to those standards is what we're trying to do.
Now, and can you define for folks, how do you can you distinguish Dash from HLS? Because theoretically, it's using the same segments, right? It's just how it's organized.
Yeah, I mean, to me, Dash is like HLS grown up. It's a more standardized and friendly. HLS is still ultimately an Apple centric way of looking at live streaming, and it works, and a lot of people have adapted to it. But Dash is sort of a look at how do we make it more standard friendly for other devices? How do we do it in a way that's slightly generic and abstracted from the iOS ecosystem?
And what distinguishes it? Like, what is technically what's different? Go ahead, Colleen.
So to take a trip back in time, just give a very short overview of how we got here, and it'll give some context. I think it was Move Networks back in the day. Like I was in like elementary school or something. I don't remember it happening. I've just been told. And they created the concept of HTTP streaming on the internet, right? So you could take video, chop it up into discrete files, because at the time HTTP 1.0, you had to open and close a connection and know the file size at the beginning. So in order to use a traditional CDN that you would have, web pages on or whatever, you had to chop it up, and then you'd have a manifest that shows where all those segments are, and you pull them down and feed it in like a caterpillar track on a cat dozer or something like that, one after another, and then you're actually rolling, right? But because you had to chop them up into these discrete files, you got this kind of nice abstraction where the manifest or the playlist that shows, all right, this is segment 1, this is segment 2, this is segment 3, they're just file URLs, right? So when Apple created the original iPhone, they created HLS, which means HTTP live streaming, but it's not just live, it also works for on demand, and you could do things like putting it on normal CDN. You could do adaptive bitrate, where it could go up and down bit rates and resolutions and that kind of stuff. And you could do live in high latency, like 30-second latency. And part of the reason was that CDNs could only do HTTP 1.0 at the time. But the cool thing about HLS was you look at the manifest and you're like, oh, I get it. So that's why my Streamline project uses HLS to teach what you can, like how all of it works, is when you look at it, you get it. Now, Dash is a better quote quote protocol in the sense of it came second. It could learn from all of the stuff that Apple did, but of course, Apple being one company had unilateral control, and they can make it simple and elegant or whatever. Dash is an industry standard, and so it had sort of a kitchen sink protocol, which not everyone implemented everything, right? But they did implement in the spec a lot of things, and so over time, a lot of the cool things that were in Dash and a lot of the stupid things that were in HLS kind of got close enough that you can actually now just create 2 different manifests, which are just little text documents. And the actual video segments can be the same to a point. Now, the point is, if you're doing fragmented MP4 with AVC or HEVC, then you're good. HLS does not support VP9 and AV1, which is obviously the future, and Apple chose poorly, but they are members of the Alliance for Open Media, so maybe they'll get on board with the future there. But with CMAF, you can actually basically use the heavy lifting part, which is the encoding and the packaging and all of that stuff. They can actually be shared between HLS and Dash. You just have to create the 2 different manifests. There's really no reason, honestly, anymore to use HLS other than if you simply want to, for me, teaching, because it's simple and easy to understand. I'm like, so it's like that, except not very human readable, but better. But on the other side, you got the obviously there's the Apple ecosystem thing, but like you can make Dash work on the Apple ecosystem, except that Apple tries to hold control of this one last bastion of like a place where you theoretically can't do anything cool, which is the iOS web browser. Because remember, Safari also is the underpinning of every browser on iOS, even Chrome or Firefox or whatever. It's just branding, but it's the same WebKit engine under the hood. And they don't allow on iPhones. They do allow on iPads. What's called the Media Source API, which allows you to deploy your own player in JavaScript instead. Whereas most things, the only place you would use the HTML tag would be like, oh, here's an MP4 or a WebM file, and it just plays back. In iOS, on web, on iPhone, you have to say, here's the manifest for an HLS manifest and have it play it back in its own player that you don't control. And that's something that they could turn off, that limitation. They just, it gives them some control and a seat at the table in the industry where otherwise they wouldn't have one. We with Streamline 2 will be showing to hack all around that. You don't need any of that anymore, and you can just go do whatever you want. So then you don't really need HLS anymore. But theoretically, that's why you might still use HLS, is for that, or because it's an easy starting point.
Now, Jonas Detel also asks, are there streaming protocols that support multiple video tracks? And I assume it's not multiple video resolutions like ABR, but really multiple video tracks coming to you at the same time. Go ahead, Andy.
There's nothing inherent in adaptive bitrate that wouldn't support multiple video tracks, because the manifest that both drives HLS and Dash could theoretically deliver different video elements inside of it.
So you could just send 4 1080p streams or 4K streams along the and then the player just decides which one it's going to grab.
Yeah, exactly. That technology sort of allows for it. The only places that I have personally talked to or sort of suppose that we would have multiple video tracks is like a sporting event where you might want to have different camera angles. And for that, it is still typically sort of a WebRTC all the way out to the client, if possible, so that you're still staying sort of as close to the house clock as possible when you're doing this, because the inherent issue that you run into delivering multiple video tracks like that is one of the tracks getting very far behind, and by very far I mean a couple of seconds behind some of the others, which could then cause serious, dissatisfaction in what you're seeing from one angle versus another.
Go ahead, Colleen.
So I'm going to have to disagree.
Go for it.
So if you want, and again, we're going to have to like say what the difference is as far as when we're talking about protocols, right? So when it comes to WebRTC or something like that, that's for a video chat thing. You could also do something like Zixi or SRT, or I don't know, like anything where you're sending like an MPEG-2 transport stream or Matroska or whatever over the internet. You can put multiple tracks in a given container. I helped create a concept called Decode, which is dash over SRT. With the high vision guys, which you might see eventually. But there's no reason why, just if you can send multiple tracks down a pipe for adaptive bitrate, you can obviously send multiple tracks down a pipe for multiple angles or whatever, right? So there, in both HLS and Dash, there are the concepts of multiple angles, right? So you can select from this camera or that camera. Just like with adaptive bitrate, you need to be able to have independent streams that you can switch between that are perfectly synchronized. You also need, as Andy is referring to, have them perfectly synchronized as well. Now, with the traditional kind of way where you would be doing streaming, it was difficult to get lowish latency and have it synchronized with ULL Dash or ULL HLS. You can also then get a much better experience there. But again, usually the use cases in those protocols end roughly around the concept of multiple angles. Now, I have a few patents on some wacky things where it's not for live, or could be for live, but like things like, imagine like choose your own adventure video or on the fly dynamic trailer generation. So when you go and watch a video, let's say you scroll down, like a Twitter or a Facebook newsfeed or whatever, I can generate on the fly a trailer for everyone based on their use case for free, essentially, because it's just based, think of it like a series of frames, like an EDL, but not really. And people see the trailer, it's kind of relevant to why they would be interested in the movie, but don't have to encode and store all of the different ones, right? And so you could also have those, just like there's multiple edits of a trailer in different countries or whatever, you can do those things. Now, you're starting to get outside of the standard, quote, quote, protocol, but standards are there because they're trying to make things easy, where if you control the chicken and the egg, you're like, I'll just take the whole thing. Somebody's already arranged the chicken and egg relationship for me. If you control both ends, which is where I think things are going, is that the people doing the encoding will also deploy the player, and the player will have the decoder in it. And then you can just do all of it, and then you can go where you want. I feel really bad for Daniel Goldstein raising his hand physically over there. I might not supposed to call on him, but
oh, don't feel bad because I have to follow up after you. But no, just off the top of my head, one particular use case. We have simultaneous audio tracks for interpretation, simultaneous video tracks because there are different sign languages in the world. Just a thought.
Great use cases.
Or even better would be one without sign language and one with sign language, so that you don't have to make that compromise.
And if we're doing audio and video, audio is a more common use case for this. And then you can imagine that you can take that concept and put it in a bunch of places. So for example, you can have stereo track, the surround track. Also interesting note, if you ever look at the waveform for a movie like Attack of the Clone, no, what was it? The episode 1 that you guys did previously as like a office hours night, you would see that the dynamic range is really big on the 5.1 track, because the assumption is you have a space with a surround sound system and a viewing environment like that. But a stereo track is like manually mixed by a person to have a lower dynamic range, so you can actually hear dialogue when you're on an airplane with headphones on or whatever, right? So I live in a building that has like shared walls. So I actually have 2 high quality stereo speakers, no subwoofer, no surround system. I want to get the best manually mixed track, not automatically down mixed track, right? So you could even do things like you could have a surround track that is professionally mixed with lower dynamic range, or for someone like my father who has hearing issues, you could have dialogue enhancement that's not, reverse engineer, well, not reverse engineer, but algorithmically generated. They could actually have that generated manually by a person, tested for people who are, have hearing issues or something like that, and make that an option as well. Because if you can do it server side, you can have it mastered manually, which, I mean, I assume this show is a perfect example of why we're not using Hangouts on Air is that if you actually have a trained person doing these things manually, you can add certain things on top of it, right? And so just like if somebody wants to opt out of, watching this angle into another angle, all right, that's allowing the manual thing to override. That's the automatic thing, but you've done that for years with audio. Now imagine what you can do with video. The answer is yes.
Go ahead, Joshua.
She answered me already.
Okay. Go ahead, Andy.
First, thank you for making me feel less dirty about using HLS to deliver separate pieces of content simultaneously. I really appreciate that. You mentioned that you've used you've pulled MPEG out of SRT in the past and put other things in there. What was that experience like? We've done some experiments on things that were similar. Was that a pleasant ride, or was it kind of was it tough to get that going?
So SRT for the most part is actually a transport protocol, right? So it's UDP based kind of streaming. They also have a file transfer thing. So here's the pro tip. You heard it here tonight. This is the coolest thing you're going to hear. Is anyone here familiar with Aspera? Raise your hand. Nobody. So massive file transfer for high quality, like master files and stuff like that, costs $1 bajillion, created by Michelle Munson and Siobhan, and sold to IBM. Anyway, the file transfer mode of SRT is basically that, but free. Just saying. But so the if you're trying to send anything over, there's a file transfer mode. You do streaming, whatever you want, right? And as I said previously, the actual the money, like what you want to do in the future is you have the protocol and the encoding working together and the muxing and all of that, rather than having them sort of, separated as far as your design. But SRT, it is separated, right? So there's no reason that you can, so like if you want to send MPEG-2 transport stream over that connection, you're good to go. If you want to have more granular things where you actually have like segments, right? And a manifest and all the relationships between those things, you can actually send those as well, right? That was not a standard though. So remember, there's the difference between the chicken and egg thing. If you want to say, have a standard where you're not just sending arbitrary stuff, but if somebody supports one thing on one side and somebody else says they support the other thing on the other side, that's when you need your quote unquote standard. So, so Desert dash over SRT is designed to be able to throw away some of the broadcasty stuff that is not useful, but keep the broadcasty stuff that is useful, and then take the cool streaming stuff that's useful and marry it up. And then you also don't have to like transform it server side unless you want to, or you can send in multiple angles and they're all labeled nicely, and you don't have to like transmux, transcode, or whatever when it hits the CDN. You just put it on your origin server rather than transforming it that way. So there's actually a talk that Mark from Haivision did at I think it was DMUX 2019 lightning talk. Should I put it in the chat on Zoom, the link to it? Or
if you put it in, you can go ahead and put it in Zoom, and then we'll have someone pop it into Makana.
So it's called Desert dash over SRT, DSRT. And so, but the thing is, now that you have all these individual little slices where you know where those things are, now you can start doing interesting things where you actually make the protocol interact with the different things. So for example, let's say that, so for me, live events are very close to my heart. I've seen enough things go sideways that could ever, I've seen everything that could possibly go sideways. So I want, they're like, oh, what kind of connection do you want at the event? All of them. How much bandwidth do you want? All of it. And I'm going to assume that it's going to screw up somewhere. So I need to bond all of it. I need to not waste any of it, and I need to adapt to it. So Caitlin, who's on the call here, is my former intern. One of the things that I had her working on during her time with me previously was the ability to measure the throughput of an SRT connection, but then feed back to the encoder that's doing the contribution what the throughput is. So in case your internet connection starts slowing down, you just turn down the bit rate rather than rebuffering, right? But if you think of something like dash over SRT, where you actually have, maybe you want to do the 1080, 720, 43, 62, 40 on the contribution side, you could say turn off the 1080p for segments 35 through 56, and then turn it back on. And then when you're done, just fill in those missing segments. Right?
Thank you so much for that. I'm going to clip that and send that off to clients. I think SRT is so misunderstood. And the way that you just described it, I think just makes it so much clearer that it is really just that transport. You can put anything through it. I put lighting data through it and things like that. But just to clear that up, that the reputation that it has is about what's going through it and not what SRT itself actually is.
You can put metadata. You can put all sorts of metadata in video streams as well if you want to hide it in that, right? But you also don't have to necessarily do that. So I'll give you another good example, which is LCVC from Vinova. It's a codec sort of, but it's not a codec. Basically, you take in a video stream that's like, say 1080p, right? And you scale it down to 540p, usually about a quarter of the resolution. Compress that with a traditional video codec, like AVC, so H.264. And then you take that residual information and you compress it with their codec, which is called LCVC, low complexity enhanced video coding. And you use all the other stuff that has been invented since H.264, which is like what, 12 years old, 13 years old, right? And you didn't at the time have GPUs on consumer devices and, you know, mobile devices that had gigahertz, you know, speed and all that kind of stuff. So you can use the, you know, larger amalgamation of all of these different things, right? And so what they do is they take that high frequency data and encode it with their stuff. So they work together. And right now, which is, you know, a hack, they embed the that second compressed stream in the SEI metadata of the main compressed stream. So it flows through a normal system, right? And when you decode it on the other side, if you have a player plugin, then it will read that and it'll do the sort of magic metadata enhancer that makes everything awesome. And you get like a 30-some% kind of compression gain or whatever. Or you can add wacky things like 10-bit on an 8-bit hardware device. Interesting, right? But the thing is there, you just have devices, if they don't have the plugin, ignoring that data. Well, now you're getting a quarter of the resolution at half the bit rate. That kind of sucks, but you're not blowing up the decoders. But what if you just separate out that stream into another stream? And you could, for example, create 2 manifests and give the manifest without that stuff to one, or a manifest with that stuff to the other. Or the player could say, hey, I'm actually LCVC compatible. So that's just like with HLS back in the day, where they would mix the audio and the video. So you'd actually have this redundant audio track where every single video stream had one. And they're like, wait a second, if I want English, Spanish, French, whatever, like, why would I multiply the number of audio tracks times the number of video tracks times the number of, you actually want to start separating all these things out. Now, Quick, for example, actually has native stream multiplexing. So you don't even have to be doing that on the container level. Super cool. Now, back in the day, remember there's MP4 files, MOV files, Matroska files, whatever. That was because you would download a file. It was a nice bundle. It's like when people zip things, not for the compression, but because they want it to be like, you know, one file rather than just a giant pile of files. Like that's what a lot of multiplexers, amongst other things, have done for a long time. But when you have a streaming service or an app or whatever, and the person's not managing files and folders, that's actually not a good thing. You actually want to like deconstruct this and only give to people what they need, right? So again, just like you're saying, we could put lighting data. Yes, that. And I can't wait for you to see some of the patents that I just filed recently, but I can't do that yet until they're issued.
Daniel Goldstein has a question for Andy Beach. Andy, can you give a pitch for using Azure rather than AWS, both virtual computers and media services? What makes the difference?
So I'll be a bad Microsoft employee and say, no, I don't care which one you use. They're both just clouds with lots of compute. I would say the big difference is AWS had acquired Elemental. And so they have a lot of first-party services that Microsoft might not have. Microsoft tends to focus more on ISV options. So the pieces that we're going to use, we do, and I will say that's not entirely true. We have Azure Media Services. The focus of that has been more around enterprise video. So things that aren't designed for media and entertainment customers. But it's still very viable and highly usable in a number of workloads. But by and large, when I'm working with a big media customer, we're using MediaKind or Harmonic or some other ISV encoder on Azure connected into a bunch of other services. Other than that, when you abstracted out the sort of elementalness of AWS, there's not a lot of difference between the two clouds.
Thank you.
Jesse Mills asks, can we hear how loud that rack of Wowza and Elemental encoders are behind Colleen?
So again, not everything where I exist is stock, shall we say. So for example, if you look, I have on my encoders here, wired up the ability to, maybe do show it separately, but basically I have the ability to light up the panels without, because I know how Alex loves his glowing panels. That's where you make all your money.
I like the green panels.
But also all of these are not the, 1RU massive, super jet engine loud ones. These are all the LO2Os, I think. Is that the one, Alex, where it's the impeller fan contribution model? And then the ones down here, if I lit those up, which these don't exist, they don't have faceplates on them for a reason. They're not elementals, but that's quiet. Also, if you have this nice, thick, short, when are you thing, like Alex, what was the HP model that I made them build back in the day? Elemental.
Well, it was was it the 151? Is that what they called it?
Something
It was
like that.
Something like that. It was a
Z800.
Z800.
Yeah. Yeah. And then of course, what's his face? Sam for years and years and years was like, oh no, we'll never do it. We'll never do it. And they finally did it just for you, Colleen. And then I walk into their office later and they have one there. And I'm like, mm-hmm.
Yeah.
But no, so all of this is relatively quiet as far as the video encoders go. The thing I still need to rewire, I've got some Noctua fans for the UPS. Sorry, I think I just rubbed my microphone on my shirt. I got some Noctua fans for the UPS, and the Dell server here sounds like an absolute jet engine. So other than that, this is all, fairly quiet, but that was not something that just happens. It's in my house and I don't have any walls, it's a loft. So like, trust me, I would need hearing protection, for that if those were like the, full on, 4 GPU models with Teslas in them that are 1 RU, but like full length hearing protection time. Yes.
Go ahead, Chris, and then Daniel.
Okay. I fully realize she may have already answered this, and I know I'm getting ready to maybe open up a can of worms here, but Colleen, what do all those things do behind you? The English version.
I'm Irish, so can you rephrase that in the form of something good?
Anything you just said, I don't understand for the past 20 minutes.
Okay, so basically there's like on-site production, right? And from there, you have baseband video like HDSDI. And then you need to take that in out of your switcher or whatever, compress it, package it up, and send it to the internet for other people to watch it. This is not for video conferencing like what you and I are doing. This is for streaming the Super Bowl, streaming a Apple product launch, not a conversation, right? But these are basically all of the Gucci high-end things that you know of and a bunch of the ones you don't know of that do that very well. So things like Andy might be able to do a good job of explaining sort of the history of the hardware appliance video encoder space, because my food just showed up and I'll be back in 30 seconds. Thank you, Andy.
Andy has a little history. Andy has a little history with the hardware.
Yeah, I was gonna say, I feel like the green servers that are stuck behind Colleen, I'm at least partly responsible for, because I did work for Elemental back in the day, a little over 11 years ago, as they were making the start. But prior to that, I worked for a company called Inlet Technologies that had a blue box called the Spinnaker. It was one of the first ABR encoders out there. And so I feel like I need to dig up a Spinnaker and send it to Colleen just to put into her museum.
And what was the big shift from mostly it was just generalized software, and then the real move was to an appliance to solve it?
Yeah, well, so all of these encoders that we're talking about are still ultimately software encoders, but the big shift, I'd say, in the Elemental timeframe was taking a dependency on GPU or something else for some of the hardware work, to make it possible to do like multiple channels out of a single box or 4K out of a single box. There was a time where it would take multiple servers to do a single 4K stream, and now we can do multiple 4K encodes out of a single box. And so that was the huge shift, and it was the addition of offloading hardware and balancing CPU and GPU really to be able to get us to decent, low latent, high quality, high streams.
The
Stuart,
end there is where I agree.
Go ahead, Daniel.
Yeah, Colleen, I was just wondering, am I seeing Gavin Belson's signature on one of those boxes?
You are. I actually worked on Silicon Valley, the show. I was the senior technical advisor for season 2 onward.
You may notice that there's someone in the show that now that you've seen Colleen might feel very
familiar.
Similar.
My hair is not currently blue, and I have promised not to swear the best that I can. Has somebody been keeping a tally?
I have, and you're still clean. You've been fabulous.
That's amazing. That is amazing.
Well done, Colleen.
But yeah, so this is actually one of the ones from the set. It's actually a like plastic piece from one of the they were called the Encodatrons, and they reused it for a later thing on the show. But yeah, all the video compression, transcoding stuff, and then most of the trolling and dirty jokes and stuff like that. That was me. Some of the hacking stuff, but eventually I brought in Movix to work on that because he's just better. So
Thank you.
Stuart Fairweather said, let's cover the basics. For the platforms our guests are from, what's the best minimum budget spec needed? Now, do you mean minimum budget by bit rate, Stuart, or money rate?
Both, but a quick aside, Colleen, I feel your pain as an Australian. Yes, the swearing is hard to control.
So my goal in life is I want to have a place here in Oakland, a place in Australia, and never see winter again. That's literally my life goal right now. Dream shark guys.
So what would you say is for? Well, I guess this is let's just open this question up to when you think about bit rate. Let's move it to bit rate for the moment. When you think about like the highest quality, what kind of math do you do to figure out like what should 1080p be, what should 720p be, where do you go with that, Colleen?
So I'm going to try to give you a very interesting answer, and then I'll give you the quick and dirty answer for what I think you want. So the thing is, there's the whole cost, speed, quality, pick any two kind of thing. It's like that with encoding and most other things in computing with diminishing returns, right? So when it comes to live video, you, for example, don't have time or something like that, right? And there's the cost of power, different hardware, whatever. Let's say that you're just looking at it from the perspective of, I've got this file, I want to compress this file. The thing is, there's also the complexity of the scene, right? So if it's just a black screen with like text on it, right? Then think of Battlestar Galactica. I'll use that as like worst case, best case example for a worst case scenario, right? So, it's like, and they have a plan, right? It's like text, super easy to encode, right? Because you just have white text, black background. There's tons of redundant information in both space and time, because video compression is based on removing everything that the human eye doesn't see and taking advantage of redundancy, right? So if there's lots of stuff that you can just throw out, easy to compress without it looking terrible. Now everyone knows, oh, look at all the motion, it gets complicated, you see an explosion, there's a camera pan and it turns to blocks. That's because when you saw that all of a sudden it looked fine before, that's because the scene got more complicated, not so much that the compression got worse or whatever. So there's actually different ways where you can allocate your budget of bits, right? Meaning, because you never want to use more than you need, but you don't want to use less than you need. So let's say that you are encoding a file, like let's say the Battlestar Galactica episode 1, let's say you have the master. It was shot on very noisy cameras. Like, you think it's film grain? No, it's just noisy. It is so hard to compress. It's preposterously hard. So when it goes from that scene to that scene, you'll see that you could compress the intro credits and stuff. Well, not credits, but and they have a plan thing, like super easily. You can make it 200 kilobits at 1080p. Then all of a sudden you're like, whoa, I need 20 megabits or more for this thing not to turn into blocks. So if you were to, for example, just want to make a file, one file, not adaptive bitrate streaming, you would use something called constant quality encoding. It's actually the default mode in Handbrake, if you're familiar with Handbrake. So, or it's a CRF mode in X264 and FFmpeg. Basically, you say, here's the file. I want you to encode it to this quality. Do whatever you need to do. Now, you cannot predict the output bitrate, but it will be correct. Now, if you have constant bitrate, that's where you say, hey, here's a bitrate. But you don't know, because you don't know the input complexity, what the quality of the output's going to be, right? You can't have it all. Now, there's one way to have it all. You can't do it live yet, and it is preposterously expensive. So if you look at the Netflix dynamic optimizer or complexity-based encoding stuff, where basically they encode everything, and then they pick the appropriate resolution / bitrate combination, quality combination for any particular scene, and each transition, like a fade, is counted as a scene, and you assemble that together. That's the theoretical best way, and it's sort of like the most exhaustive, we'll just try everything and see how it works approach. But
now, is it changing during the show? I mean, is it?
Yes. Oh yeah. So here's the interesting thing. You've got the relationship, because if you have a 1080p video, 1 megabit, and it's simple, like, again, that scene where you have the letters in the black background, 1080p at 200 kilobits, that looks fine, right? In fact, there would be no reason to create the other resolutions because you're already low enough. But when it switches to the other scene, now you would actually be like, if your budget is max 2 megabits per second,
you're done. Like you can't, like you actually would only want to encode up to say 360p or something, because there's no reason to encode 1080p if to hit a good quality at that resolution, you're going to have to go to 20 megabits if none of your customers have 20 megabit internet connections. So the real difficult thing that most people don't get is that it's actually called adaptive bitrate video. The problem is that, and that's the part that matters, most people treat it as adaptive resolution video. Resolution is just one more tool to achieve at a given bitrate the quality that you're looking for. So theoretically, even without adapting, you should be able to have one, as I coined the term, bitrate lanes, right? You should be able to have, like, say, a 2 megabit give or take some wobble lane, like a 3 megabit give or take some wobble lane. But those resolutions are going to change completely dynamically on the fly relative to the simplicity of the content. And nobody should know.
Well, the reason I ask is that, so I can't watch an action film on Netflix because it stutters when it changes scenes, and I'm starting to piece together. I've just ruined a whole bunch of people's Netflix experience. That once your eye knows that it's stuttering, you'll see it all the time, like I do. And so I noticed a stutter, and I thought that it was some kind of keyframe issue, but it appears that it's the problem is deeper, and it only happens for me.
Hold on.
I think it only happens to me on Netflix, but
so hold on. You're actually bringing up something interesting there. So when you say keyframe, you mean intraframe and possibly IDR frame, right? So a intraframe must occur whenever you change resolutions on legacy video codecs like HEVC or H.264, VP9, AV1, those sort of things are, and granted, VP9 and HEVC are the same generation, but they have a thing where you can actually switch on the fly. But more interestingly, on AV1, there's a thing called an S-frame, but we'll get back to that later. You can actually, normally you would have to start everything with an intraframe if you're starting on a new bitrate, not a new bitrate, sorry, a new resolution, or ideally like a new scene, you would do it because, you know, it basically refreshes all of the spatial information, not just the temporal information, right? If they were going to switch resolutions using a codec like HEVC or AVC, it would make sense for them to do that at an iframe. Yes. That is also why, if you want to see something really interesting, watch basically any movie platform with, like, I don't know, basically like say there's like an image on the screen or like just a forest or something, and look really close. You'll see a pulse every, say, 2 seconds, 5 seconds of quality, where the slight artifacts move around every couple of seconds consistently at like a beat. And that's because they did distributed transcoding to save time and money, but they didn't do bounded bitrate constant quality encoding. They did 2-pass encoding and made the mistake, and therefore the quality at the end of one segment and the beginning quality of the next segment are not identical.
We used to have to deal with that with rendering. We used to have to rent when we were rendering in large farms for VFX. The different chips would give us a different grain, and then you'd have all kinds of problems.
So what you need is temporal coherence, right?
Right. Now, Andy, are there any rules of thumb as you start to build like larger, infrastructure when you're dealing with a certain resolution, or do you have ways that you do that math that's just kind of just baseline?
Yes and no, and it's sort of constantly a moving target, right? Because quality of the ability for a codec to encode and deliver will always improve. So the bitrate for now will be very different. The target bitrate for now will be different than 2 years from now. 18 months was generally the period of time when I was hardcore, just doing nothing but encoding for my life, was the sort of time frame that my settings were good. And then after that, I would have to throw them away and start over because all of the technology changed just enough that I was going to have to readapt.
But that was a lot of it was probably decoder compatibility, right?
Yes, by and far, a lot of it is that, but then it's also what is the contribution encoder able to do for me on the front end in order to get me something that's normalized enough that I'm encoding it in the cloud somewhere. So it's kind of those two pieces.
I would say some things have sort of normalized, and that has become a larger, the same problem exists, but in a different part of the stack, right? So the contribution encoders now, like, it's not a problem. You can buy a $300 hardware encoder. It's built into your phone. Like, hardware encoders are like my open source project. Literally, here's a good hardware encoder. Go, it's free, whatever, right? But when you're talking about delivery, like, and again, in the source project, I paste in like a little bash script that just has like a rule of thumb, like just do that thing that I gave away, just do that. And if you want better quality because your stuff's more complicated, just turn it up by a percentage, the bit rate or whatever. And that's just if you want the simple rule of thumb, there you go. Also for HLS, Apple provides that as well. The hard thing is when you have a larger platform, like let's say a Facebook Live, YouTube Live, whatever, trying to, this is always encoding, right? You can set things to like encode super fast, but you don't get a ton of compression, or you can make it, they literally have a thing that says very fast, super fast, sorry, it's ultra fast, super fast, very fast, fast, medium, slow, slower, slowest, placebo. And placebo mode is not better in any particular way, but it will just burn up your CPU forever and you'll get a little bit, possibly, maybe theoretically, smaller file, right? But that whole thing of like, it's not just how much CPU you use per file. Now you have multiple bitrate lanes. Now you have lots of different streams. Let's say you're doing multi-angle streaming. Do you make your program feed that switched? Do you allocate more of your resources there or to the individual streams? Or do you, across your entire platform? Because if you want to treat everything the same, you're probably crazy. Because if your CDN bandwidth is, like most places, your top couple of streams is going to be massive viewership and your long tail is going to be very long, right? And so being able to use that stuff dynamically across your entire platform so that you don't go to the poorhouse, that's yet another aspect of it. But if you're doing contribution, basically, like find yourself a test clip, like here, I'll give you an easy one. Go to, I can even paste one that I created that I made at the Gay Pride Parade with a GoPro on a gimbal and everyone's bouncing around and like it's super complicated. Or you go to zip.org, XIPH, and they have a thing called the DERF set. And there's a file called crowd run. It's just a bunch of people running, right? And it's just super hard to encode, okay? If you can encode that well, everything else is easier. There's your answer. So everything is just, it's all downhill from there, right? So if you find your hardest clip, throw it at it. You can just set it there and you're fine. Just make sure that you.
I use, every time we go to Bodega Bay, I tap my 6K Blackmagic camera and I just shoot footage of the ocean. and there's a constant question about why I'm shooting of the ocean. I'm like, encoding tests. I'm just constantly.
I think every encoder has their encoder killer set of files. Yep. I haven't even done that for a living for years, and I've got two that are my go-to. It's ducks taking off, a series of ducks taking off from water.
I'll give that a B+ on hard.
And confetti. Then I've got a NASCAR clip of that was shot through two different fences. And the camera is both panning and zooming simultaneously with the car.
So again, hold my beer. I have dropped into the chat here. You guys can read this later. A 5.3 gigabyte ProRes file that I created. That is now, granted, there are artifacts in the file because it was done on the hardware encoder on a GoPro, and it's still, but like that's also a real world use case. Right, that's also not super clean, but like it's good quality, but it's 4K 30, and it's called 4K Gay because from the Gay Pride Parade, I also find it very funny that I was able to contribute it to like the Alliance for Open Media test set, and people look at the file name and they're like, "What's that going to be?" Oh, okay, that's fine. But yeah, so normally there's all sorts of licensing issues around using test clips, and a lot of people will use like Big Buck Bunny, right? Big Buck Bunny is not, or Tears of Steel from Blender, it's like an open source video clip. That's not a good test clip, because either of them, right? Especially Big Buck Bunny, because it's so simple, because it's like CGI, like Pixar, like old timey Pixar style, super smooth, easy. And both of them are 24 frames per second. Tears of Steel is 2:3:5 aspect ratio if you're doing sports or whatever. It's not like that. Get your sports clip, well, find the content that's similar to what you're doing. And I'm not saying necessarily that film is always easier, because if you have film grain, that's just a huge pain in the butt too. But like find whatever's your worst case scenario, tune your end-to-end pipeline. Now remember, machine is only strongest, weakest link. And then make sure that you have enough bandwidth to do that. And it's all downhill from there, unless you want to make it adaptive. Because the thing is, if you have to, and Caitlin can speak to this, my former intern, if you have the whole pipeline completely tuned where you're running at 99% capacity, so you hit 100, you're over, you also have no room for fluctuation. Now, most people say, all right, then we'll cut it in half. You can do that. Or if you really want to make it good, what you say is, hey, encoder, use all of the bits, but no more than you have dynamically. That's the answer. That's
Good,
what I had Caitlin work on.
Stuart, real quick.
Yeah, it sounds like from a cinematographer's point of view, when we're dealing with the bit rates, I need to be looking at having the least amount of motion happening during transitions or during edits, and be able to ramp it up and down to take advantage of those changes in the compressor you were talking about earlier. Would that lead to a better quality image for the viewer? Like if we're considering it right at the point where we're filming and where we're editing before we do anything else. And what about with live production? Would it help to have complementary camera angles that we switch between?
So no, when it comes to camera angles, and I will give you a easier but slightly different answer that answers your other question, right? So I think what you're saying, we'll start with the non-live one, we'll start with the cinematic one, right? What you're saying is, what if I want to take the time to tune it so that if we use the content a little bit so that it looks as good as possible once it's had the crap compressed out of it, meaning we can get it down to, 100 kilobits or something for 1080p or whatever? And the answer is yes, right? You could totally do that. The other thing though is that how do you know what is complicated or not? So when you said, what if you have complementary camera angles? Depends how complementary, but they're probably never going to be that complementary. Whenever you get a new scene change or a camera angle, or sometimes even just a slightly complicated thing, the encoder inserts an intraframe to refresh all of the spatial data anyway. Assume that every time you cut, you are inserting an iframe. Now an iframe compared to a p frame or a b frame, right? Meaning there's like all the spatial information in an iframe, p frames and b frames or s frames or all ref frames. Those are each progressively smaller. So whenever you cut, you're actually increasing the data needed. So if you have longer shots, that would be an easy way to do it. Now, the best way that I could tell you as far as how to handle that, as far as figuring out what works and what doesn't, is download Handbrake, set your CRF, which is the constant read factor, that's the constant quality encoder setting, set it to say 20, right? That's a good high quality for the internet, a little on the higher quality side, but it's good, right? Run 2 different versions of the clip through it. You'll get identical quality, but if one's smaller, that means that you did a better job of, if you're trying to, tuning the clip to matching the, trying to make it smaller. So if you're saying both these clips look good, one's smaller, you just made it smaller relative to that because you made it less complicated, right? There's less things moving on, right? So if you look behind me right now, I'm moving around a little bit, but those encoders behind me aren't, right? So you can just keep representing that in time, but now I'm whoop, whoop. Or if I actually went to go start screen sharing or something and they were in the same stream, now I'd have to refresh everything. That it's a big burst of data. Now, if you want to try to actually make things simpler, there's a lot of stuff where the human eye, the concept of, so you can take advantage of the human eye's an ability to see motion, because if, like, let's say I have a book and I'm shaking it around in front of you, you can't read it, right? So it could actually be blurrier, right? And so you know how people are like, oh no, I don't like the soap opera effect of 60 FPS. I'm not talking about frame interpolation. I'm talking about, like, some people want a certain amount of motion blur, and that's kind of actually how the human eye works. You can actually make things, actually, I just noticed that my camera is getting higher latency right now. That's weird. I'm gonna close my browser over here because this is what happens when this laptop gets a little warm. But if my camera starts getting out of sync right now, my apologies. I can also stop my video so that it's not distracting, Alex.
It's fine. It's fine. I'm gonna shift gears on you though. Why you did, go ahead. You finish? Oh, you got it. Oh, I got a question for Andy.
So sorry, where was I?
I think your latency is slowing down there. Whoop. Can you hear us, Colleen? Oh, he's gone. She'll be back.
Yes, I can. I'm just hitting that. I'm trying to get the thermals on my laptop down real quick.
Oh, got it. Okay. Yeah. So this is a question for Andy to start with while Colleen is cooling the laptop. This is from Leo Mendel from London. He said, so far streaming has lagged broadcast in terms of quality. 1080p has only become the norm for some platforms in the last 24 months. Can you see streaming taking over and delivering 8K, 16K before broadcast in the future?
Before broadcast is a tough question. They will absolutely get there. It is tough unless we change the delivery model, because ultimately we're still unicasting content, meaning that the more viewers that we have for something over the web, it's inherently more expensive than it is for a broadcaster. A broadcaster just sort of puts a feed out there and everybody watches it, and they're just picking up that feed. They're multicasting it, and so it's easier for them to ramp up the quality faster. They may not think that is true because they are still also heavily reliant on hardware in a lot of cases, and it means hardware swap out. But at the end of the day, because streaming is still built around a unicast model right now, it means that the more popular something gets, the more it's going to cost me to deliver it to that wider audience. And so that becomes the challenge. That is, there are paradigms that change there, and there are things that will evolve for it. But right now, it's going to be more expensive for me to deliver 8K over the internet than it is over a broadcast feed.
Was BitTorrent onto something as far as like, could you stream with that type of peer-to-peer solution?
Yeah, I mean, look, peer-to-peer is like a super intelligent way to defray this. Absolutely. And a lot of the technologies that we use for even this type of interaction rely on peer-to-peer in some form under the hood in order to distribute the workload. And I'm sure that we will see versions and flavors of that come back. It just won't have the BitTorrent title with it, because that is a dirty word in the entertainment world.
No, they haven't gotten over it, is what you're saying? Haven't?
No, that P2P they might be able to live with. BitTorrent is that one's a dirty word.
Daniel Goldstein said, Andy and Colleen, do you have any insight into Zoom's AV protocol? How are they able to send 1080p at crazy low latencies? Do you have any idea of how that works?
So I'm pretty sure, and Colleen may have different interpretations of it, but under the hood, they are using WebRTC, which is part of what they use to reduce latency between sort of people interacting and talking. I'm confident they're also using pieces of peer-to-peer under the hood as well for that, although that part I'm not 100% sure. The only other sort of trick when it comes to more of this flavor of media communications is using something more that's more analogous to SVC or some of the codecs that will do some dynamic shaving of bitrate on the fly very quickly. It's sort of slightly more nuanced and more adaptive than the ABR stuff we talk about for media and entertainment workloads. It's sort of quicker and easier to feather down and then build back up quality. But that is generally the pieces that go into that. And Colleen is back, so she will say,
yeah, sorry.
I am
You
wrong.
can also explain what happened.
And then she'll explain everything that
you actually are wrong, yes. But I
it.
love you, and I hope I make you proud when I explain to you how you're wrong. And it's only because of people like you and Alex who got me here. I'm just a young whippersnapper, but you did this.
Look, it's nothing but love, Colleen. That's all. I every time I show up, I can't wait to find out how I'm wrong, according to Colleen.
Well, I mean, then start being right or something. So WebRTC is a standard where you can do video conferencing in a web browser, right? And there's also this weird thing that they awesomely implemented, which is called WebRTC data channel. So WebRTC was never intended to be a scalable distribution mechanism. It was meant for, like I said, you can have a CDN, you can do something like HLS or Dash. You're good to go for, a very large live event or on-demand video or whatever. Things like what we're doing now does not scale. It's an expensive thing where you don't have commodity servers. Everyone's hitting you. It's very specialized stuff, and it costs more per second or minute to do something like that. And you also get reduced quality for a given thing. Now, the data channel thing, though, because you can transmit like a file kind of thing, you can actually basically hack the equivalent of live video BitTorrent in a web browser. Interesting. So like companies like Peer5 or Hive. Hive is available with like a Facebook Workplace, right? And so here's a very clear example, right? Which is if you have a corporate all hands and everyone's in the office and they all want to watch a stream, you're going to blow up the internet connection for your company because nobody's going to provision their internet connection for their company at, absolute max capacity, right? Cool. But they're all watching the same thing. So they can all start sharing segments with each other, right? So just like BitTorrent, you don't need a central origin server. You have this swarm, this cluster, right? You can do the same thing for live video. Now, when you say it's for low latency, yes, except that it's not used in that way, in the sense of that the low latency aspect of WebRTC was why WebRTC was invented. But it also, to get the low latency and to make it affordable, they made peer-to-peer connections as opposed to client-server connections possible. So if you hack in using the file transfer version of that, you can build basically BitTorrent in a web browser live with no plugins. And so that's one way of scaling out a live stream, like if you're doing multicast or something like that. The thing is that then everyone's giving up their IP address to at least a couple of other peers, just like BitTorrent. So if that's okay for your use case, like corporate streaming, because if I'm watching the CEO and you're watching the CEO, then we're both good employees. If you're watching something not good, and Eric's walkout right now, if he's watching, is really sad that I didn't use my normal example, but it's a clean show. And then other people might find out that you're watching it too, in which case that getting bits from that same system at the same time, you can infer that somebody else is watching the same thing. So there are privacy implications there. However, it is a great way of scaling out a system in a way where you don't have to pay for all of the bandwidth. So if you watch, the introduction of Carla in Silicon Valley, she actually explains exactly this technology, where she says, I'm using peer-to-peer over WebRTC and VP9 ABR and blah, blah, blah. And then you pay for one stream going out, and then all the viewers pick up the rest of the tab. That's like the intro thing, but it is not a very good low latency thing currently. But one of the ways you could get there, yes, is by using SVC, scalable compression. Now, SVC was a profile of H.264. With VP9 and AV1, now it's actually a real world practicality in a browser, because as Andy could, remind everyone back even in the Flash days, they're like, oh, we're going to support SVC in Flash. It's going to be great. Never happened, right? Now, VP9, AV1 are the ways that you can do that. And as I said before, layer-based codecs actually in a low latency model give you a ton of options for being able to do just like, so like with H.264 in HLS or Dash, you have to compress the same thing in multiple independent streams and you select from them. A layered codec, you have the base, and it's like one of those books when you're a kid where you have the base and it's like transparencies with some stuff on it. You keep adding in details like, here's the machinery, here's the people, right? And so it's the same thing for scalable compression. Historically, it's been about a 30% quality per bit hit to be able to do that, but you didn't have to encode the same thing 8 times. With something like LCVC, now you have a layer where you have a base and an upper layer, and you actually get a quality enhancement per bit about 30%, or bit per quality enhancement about 30%, which is cool. But you can combine these things where if you offload stuff to the client and you want low latency, that's when you do the scalable thing. But if you want to, and also there are efficiencies when you're having a swarm and not a server to edge model of using SVC. Right. You're right, Andy. But it's not exactly the same thing.
Now, it's funny when I didn't know that Colleen was working on Silicon Valley, and when they introduced Carla and she gave the explanation, I was like, Colleen's working on this film, on this show. like it was like I immediately, it was like it just clicked in. I was like, there's nobody else that I know would talk like that. Ray Maxwell asks for the two of you, if you were going to suggest real quickly places for, can you suggest books or websites that a beginner can read all about streaming protocols? Like, where would you send someone to ramp them up? Andy, do you have any places that you would like to send somebody?
So if I want to be dirty and filthy, I'll promote my own thing. I wrote a book a couple of years ago called Video Compression Handbook. And really, honestly, the only reason I wrote it was because
it's like the tale of Gilgamesh. If you want to find out how we all got here, like,
yeah, I mean, well, and there's an older version of it called Real World Video Compression. But at the end of the day, the reason that I wrote them was at the time that I wrote the original book in 2007, all of the books that I could find about video compression were by like PhDs and Pete Symes and the SMPTE board. And I was like, okay, cool. I don't understand any of this stuff. I just need to know what I need to do to get online. How about that book? So I wrote that book with Peach Pit a number of years ago, and then I updated it in 2018 because everything had changed a whole bunch. And everything has changed again, but I've already decided I'm not going to write the next version of the book. That's on Colleen.
So here's the interesting thing is that Alex, so I've got my open source project. I'm not trying to plug it for that. I think it's probably not the right. So I try to make things easy, but my version of easy is not as easy as like what Andy did for that book. So I think there definitely needs to be a bit of an on-ramp there. So I actually recruited Alex for when I gave the first talk where I released my open source project, which is Streamline. And he gave the intro to the sort of basic HLS dash, that kind of stuff, and how all these things
which
work.
everybody here has seen, because I did it on a Friday here, so I did like a little quick overview, and I'm working on the next update of that.
And the end-to-end part of that, right? Because you actually see, you and I are like two of the weirdos. You're more on the sort of creation ninja side and more on the delivery side, but there's not a lot of people who can speak to the whole chain. And really the question is, what matters to you relative to your job or what you're trying to do? I prefer to just say, I'm going to try to teach you about everything, and then we can dive in where you want. But I find HDSDI is like a nice little, cutting point, because a lot of people know about up to there, and it's a standard and simple and easy. And it's like, cool, take it from there. Go buy some black magic stuff or whatever, and then you can learn about it elsewhere. All I would say is like, don't go to Streaming Media Magazine, don't go to streamingmedia.com or Streaming Learning Center or any of that stuff. The problem is that all of that stuff is like the people who actually work on this stuff for a living aren't writing articles about it, and the people who are writing articles about it aren't working on it for a living. You kind of need to just get your hands dirty, right? And so once you're there, then you can start diving through and understanding it. But the issue is, it's like if you want to try to eat a whole hamburger at once, right? If you go in and you want to see like the comparison of, VP9 versus HEVC or whatever, and then you're like, okay, VP9 or Dash, and it's like, yes, I mean, that's the same thing. Like, what not? But like, they're different things, right? I think the reason I'm trying to, I'm not saying it's good or not. I'm saying if you know how to use, a command line and a bash script and stuff like that, and Linux, that's kind of where you're starting out with me. For Andy stuff, that's if you're trying to understand how the compression part works. I think there's a huge need to try to learn more about these technologies, but I think more importantly, there's more of a need for the people who are building the core technologies like HLS or Dash or Decode or all this kind of stuff to understand more about the world that you guys are literally pioneering right here. And I'm not trying to blow smoke up your butt, but I'm saying we are so amazed these days to make video appear on a screen at all that we think we're done. We need to make our stuff easier so that you don't have to understand as much.
And I think that we have to I think it does help in some cases. This gets back to a little bit of what Stuart said, is that knowing as content creators what the compression, how it affects the pipeline is, understanding this well enough, so, a lot of times, people ask me why I use a lot of Super 35 sensors. Well, I know that Super 35 compresses better. Short depth of field is going to compress better than everything in Focus,
But should you have to learn 3 pipelines is my point. Like I said earlier, if we can create one with a dialable latency. So I'm saying that we need to, partner and make these things a little bit more, and as we said earlier, as we make things easy, things are going to get more complicated. But I think we need to try to use, on my side, on the infrastructure, protocol, compression stuff, try to make it easier for people who are like the software engineers who are actually building, the applications that use these things. So they're not just like, haha, I've done it. Video goes from point A to point B, but they can focus on things like, what you're doing here, where there's, this person, that person, switching, scalable live streaming. If we can make that stuff easier to both implement over there, but then to you guys, give you simple rule sets, and also make it so that you're not worried about things you should not be worried about. Like the idea of what settings should I use, to me is ridiculous, right? Because with the Clearcaster, right, I was like, hey, your encoder is a computer on the internet, and you're sending it to a computer on the internet, and they're both doing it over the same standard. What if they just, I don't know, talk and just figure it out? And what if it slows down? Maybe because it should be able to know that, it turns itself down and back up, right? If we can remove those complexities, there are going to be things where we actually need to then empower the creator to do a better job with what, it's just like with a camera, there's the auto mode, but then there's the like, all right, do you want the shutter speed or that or whatever to get the right effect? I want it to be on the streaming side, empowering people to make those decisions in a way where they don't have to learn arcane stuff to understand it at all.
Now, are you guys familiar? Have you been tracking the NVIDIA grid? Is that something that this is from Mark Hadley? He was curious in Seattle. Has that been something that you guys have looked at much?
The grid
not
is one
sure.
of their GPUs, and it's got a couple of different functions to it. Sometimes it's for like ultra low latency rendering and game streaming, or remote workstations or stuff like that. If you look at like the difference between a Quadro and a actually, hold on, I think I have one of the Streamline 2 boxes. Oh no, it's the other one's in the closet. But if you want to compare like the Quadro cards to the GeForce cards, right? You can get like an $8,000 Quadro or a Tesla or a Grid or something like that are more for GPU computing or whatever. But when it comes to streaming, you're actually talking more about the NVENC portion of it, the encoder, and that is a small chip, just like in your cell phone. I keep hearing my audio cut out. Am I cutting out on you?
No, you're good.
Okay, cool. So the encoder part of those things, it's not like back in the day when Elemental was actually trying to use the GPU itself. So there's a graphics card. On the graphics card, there's RAM, there's the GPU, and there's also a hardware encoder. Now, the hardware encoder just does the video compression part. The Elemental guys originally were like, we're going to write an encoder on the GPU. Eventually, they said, screw all that and just put it all on. And that doesn't count. That does not count. That does not count. So we're going to do it on CPU, where you could actually do even more, and CPU's got faster, right? But if you're going to do something where you're actually doing transcoding, for example, the video's already done, you're just going to resize it, maybe change the color space, compress it, and stream it. You're probably actually using the NVENC portion of it, which is the NVIDIA encoder, or NVDEC, which is the decoder, and you scale on the GPU and set it out. So, interesting fact, Quadros, where they will sell you, the thing where you can actually transcode super fast. You can do as many streams as you want, where there's just a bucket of pixels, and you can subdivide that into however many, frames / the resolution of the frame or the frame rate that you want, pixels per second, essentially. And then the GeForce cards, which are the consumer ones, you could do 2, and I heard maybe recently it's 3. You'd have to buy an expensive Quadro card that is slower as far as the GPU goes, but in the end, it's every single NVIDIA card has the same NVENC encoder on it. And after the Turing generation, they actually got good quality. They're actually equivalent to X264. So here's the trick. You buy the GTX 1650 Super. It has the same Turing generation encoder chip as the RTX generation on, which makes the quality as good as the RTX cards, which is as good as X264 Medium. But it is not a price of an RTX card. You buy them for like $150, although I hear right now the Bitcoin miners are ruining all of it. You can buy them for $150 instead of like $1,000 or something for a big ass Quadro. That doesn't count either, Quadro. And what you can do though is there's actually a hack on GitHub where you can actually run it and subdivide as many times as you want. You can unlock it. So that $150 graphics card, as far as the speed of transcoding, is the same as a Grid or a Tesla or anything else. It's cheap, it's small, it's affordable. But the main reason I'm telling you this is not that you're going to go do it, and you might or not. It's more just to show that it's actually that little chip, that hardware chip that is doing that transcoding. That's actually the video processing part. You don't need to spend, or the video encoding part, you need to spend for any of that.
And now, Andy, from the scale side of what you're doing, are you focusing more on? Is it more? I guess I would say basic CPU power, or is it a mixture of CPU and GPU, or a specialized hardware?
Definitely a mixture of CPU and GPU, but a lot of what I'm trying to do is based in the cloud. So it's what is available, and because I work at Microsoft, a lot of that tends to be at Azure today, which does have NVIDIA, but it has specific NVIDIA cards. So I know I have a mixture of NVIDIA cards, I have FPGA cards, and I have other things. So I know places that I can route the right things depending on what I want to do with it. And again, most of that is not going through specific like first party type things. I'm going through a media kind encoder, or I'm going through a harmonic encoder. So I'm relying on them to abstract out what hardware and software they want to run on. Mm-hmm. And I'm worried less about that. And it's more, what are the qualities I want to hit? What's the latency I want to hit? And then I'm assuming that they know how to do the other piece of it.
Yeah. Go ahead, Chris, real quick.
Yeah, so a quick question. If I shoot something on my Blackmagic 6K at constant bit rate at 6K, edit it in 3K or 4K, and I just simply click the YouTube button to save it out, does this bypass everything you guys have been talking about for the past hour, or am I the type of person that you all just laugh at?
Well, a
Sorry,
lot of times
where's the YouTube button?
it's mostly just you're talking about a lot of what we're talking about here is how do we encode it live, as opposed to the export of a basic file. I mean, they're similar in the sense
From what
that they're
software is
compressing.
the exporting? Because I might have actually done that setting.
What do
Premiere or
you
something?
Resolve.
Resolve. Okay, yeah, I didn't work on that one, but
I can tell you exactly something about Resolve. Never export to H.264 out of Resolve. They're still working on that, but I can tell you with absolute assurity that the only thing to send out of Resolve is stuff like, MXF, your ProRes, they have totally screwed up their H.264.
and that's the
encoding.
thing, that it should be for everything. So like when I worked with Premiere people at Adobe, and I'm like, okay, they're like, we need a preset. And I'm like, okay, well, what you need to do is you need to like figure out relative to the content, just give me a setting. And I'm like, okay, here you go, but it's not going to be right. So I will tell you the actual answer right now for file-based stuff. Export your video in a mezzanine format like ProRes or DNxHR or whatever. Take that, transcode it to a constant quality of a CRF of 16 or 18 if you need the file smaller, or 10 if you just like throwing bits at it, right? And then it will end up being the correct size. Upload that. So take your file, export it in ProRes or DNxHR, throw it into Handbrake, CRF of 10 if you're crazy, bandwidth fast, and you want a big file, 18 if you're a reasonable human, 16 if you just want to play it safe. And you're good. Just upload that. That's your answer. But now the problem there, of course, is that when you're exporting it, you have now a blocking process. You have to export it, and then you have to encode it again, and then you have to upload it. There's no reason, because constant quality encoding is not a weird thing, that DaVinci Resolve or the people over at Adobe can't use something like NVEnc or QuickSync or any of the other hardware accelerated stuff on your computer, and then do a constant quality encode export and upload it as you're exporting it. So you could actually reduce the time from render and export and render, encode to a mezzanine, export, then encode, and then upload. You could actually just be doing the whole thing simultaneously, and then you could also make it better because somebody's turnaround time is not 3x, right? But for now, that's the rule of thumb.
Now we're going to go into speed round here. We're running towards the end of the hour. We're gonna burn through a bunch of questions that we have in Mukana. So for Andy and Colleen, this is going to be 30 seconds to a minute max on the answer. So we'll just
no pressure.
No pressure. So Jesse Mills asks, what hardware software can I experiment with now to stream via AV1 in a non-cloud workflow?
FFmpeg.
Sorry?
FFmpeg.
Yeah.
Mm-hmm.
Or I think Handbrake might even have it. There's actually I'll share a name later on GitHub, but FFmpeg.
Jan Landy said, amongst all of the streaming services available, i.e. Amazon Prime, HBOGO, Showtime, Apple, which of these services provide the highest quality encoding and will make watching the content subliminally or in real time more enjoyable?
Are we talking live or on demand?
I think we're talking on demand.
Yeah.
On demand, I would probably say the very few versions of Dolby Vision on Amazon Prime, but you don't even know if you're going to get it. Here's the trick. You go to Amazon Prime and you look up a movie like Chappie or Elysium, right? There'll be two versions of the same movie that come up. One that says UHD and one that doesn't. It's two banners, two prices. You buy the one with UHD. And if it happens to be Dolby Vision, that's really good.
I'll be weird and archaic with mine. For whatever reason, Voodoo also always had the best encode qualities of anything I was looking at.
The funny thing is that I'm really bitter about Voodoo because they Henry V is the only reason I have Voodoo is because Henry V is only available. The Kenneth Branagh version is only available on Voodoo, and the compression quality is the worst I've ever seen. So evidently they must have just decided that movie doesn't matter.
I don't know if they biffed it on that one, but yeah.
Well, it's probably not their encoding. It's probably their source
file. They were the
file.
early adopter on Ultraviolet, so they were the easy place to sort of go grab everything from everywhere. But whenever I was watching the encodes from there, if it was their sort of enhanced encode stack, it always looked really good.
Yeah, I don't know what happened.
Well,
it might have been, maybe it was a bad
They were
source.
more into the pre-download thing, so that probably helped.
Stephen Kimbrough asks, and I think we kind of touched on this, but just real quick as a bullet, with all that's going on in streaming, what protocols should I focus on and really know well?
CMAF, HLS, and Dash. Sorry, my headset's dying, so I switched to AirPods. Hope it's not too bad. But CMAF, HLS, and Dash for delivery, scalable, live, and on-demand.
Right.
Copy that.
For delivery, those are all the right things. I think if you're looking for like ingestion into clouds to do encode, SRT, look into that, learn more about it. Zixi is there, but I don't know. I like SRT more.
So
Zixi is the Gucci good stuff if you can afford it, and if you want to if it's ultra important, you're willing to spend the time. Zixi is just
what distinguishes Zixi from SRT?
The license
quality, which is the same thing.
Oh, it's not the quality. Come on, Colleen.
No. Let me explain. It's literally that. So Zixi exists. It existed. It's great. They did a really good job of implementing it. And SRT is an open source reaction and response to that.
Right.
There you go. Right.
They're both UDP transport deliveries. Zixi is one that comes with a license. SRT is an open source. So
yes,
you're on.
Because they're not making any money off of it, it moves slower. And then people like me come in and are like, let's add this, let's add this, let's add this. Whereas Zixi is a company where you pay them money and they do things and they've already implemented it. And but also buggy and hard to get working. And then once it's working, don't touch it. But right now, it is a more sophisticated implementation that you'll pay out the nose for. So remember earlier when I was saying SRT, actually it's a file transfer mode that's basically free Aspera. Cool. Zixi, it's like Aspera is the file transfer version of that, and Zixi is the closed source whatever thing. But you also, it's like, do you want to buy an NSX? It's the practical car you want to live with. It's kind of fast and kind of fun, or do you want to buy a Lamborghini Countach or something? It's usually it's pricey, it's expensive, it might be broken down sometimes. There's different things. One's cooler, one's not. But
do you think that that Zixi is measurably better than SRT in what ways?
So sorry, my food over here might be boiling over, just turning it off. So when it comes to the actual throughput on a connection and the ability to maximize the throughput, meaning if you have a given internet connection, it's got packet loss, it's got latency, there is a measurable difference between Zixi and SRT performance. Is it huge? Not really. But it's there. And so that's the difference between why somebody buys the Ferrari 360 Challenge Stradale or the Ferrari 360. They spend more money for that tiny little extra bit of performance. If you really want the Gucci stuff, you buy the special version where they charge you more and give you less, right? For lighter seats on the cars.
If you really want to buy it, go with Zixi.
Right, but that is a separate thing then. Would I adopt Zixi right now? Probably not. Right. I'm not trashing SRT. I'm just trying to call it as I see it.
It sounded like you were trashing SRT a little bit.
No, I love SRT, and I want.
Some of my best friends are SRT.
Why don't we talk about wrist? Huh? Why don't we talk about wrist? It's all on the wrist.
It is all wrist at the end of the day. We're 4 minutes from the end. Let's throw another acronym.
All right. Benjamin Antipid asks, what software encoder do the guests prefer? Do you have any specific one? Open source alternatives. What's your favorite encoding? Sorry. Use case, Benjamin.
Both for two things. One for live and one for recorded media.
And what do you mean live? Do you mean OBS, software installed on a computer, or do you mean FFmpeg? Okay, so OBS is great, but it's not an encoder.
Right. So what encoder would you recommend?
So OBS is a video production tool that does taking sources, switches, all that kind of stuff. And then the encoder that it can leverage can be hardware, software, whatever. X264 is a very high quality encoder that you can select from there and utilize properly. You probably want to go to the advanced setting, and you probably even want to hack it and actually use the recording setting with the output and do some weird transmuxing stuff. But that would be the way to do it. OBS is great. It is insanely unreliable, just like Wirecast or anything like that. You have to dial it in and test it because it can do anything, anything, good or bad, right? And so once you find a configuration, so I recommend you get a Linux build. You use Ubuntu, you put it on a very predictable set of hardware, and you burn it and you make sure it works, and then you don't touch it. You make an image of that. You write it, you DD that to a disk, and you only use that once it's QC'd, right? Just like a professional release process for like Elemental or something like that, right? But don't just throw it on your computer with a bunch of other stuff and expect it to be reliable for a show, right? But if you test it, it's awesome. I would go with OBS.
And Andy, do you have any preferences?
I mean, it almost always comes back to FFmpeg. It is the cheap and cheerful, like it's the easy Swiss Army knife that we all end up using at some point. And so that is the easy place to point people back to. That is also a trap because it is like I don't know, that it'll bloom into 1,000 different problems and layers for you as you get into it. But if that's an area that like if quality and latency and everything else is like important to you, and you want a tool that's just free and easy to use, or at least free, not necessarily easy, but free, that's the way to go.
And again, though, the OBS project is built on top of like libav and has FFmpeg associated stuff in it. So when I said you can do the recording advanced mode, you basically can unlock all of the capabilities of FFmpeg if you know how to use it, except it's even harder to use. But FFmpeg is more for streams or files where you take it in pre-done and you send it out, file or a stream. OBS is more for I'm taking hardware and switching it and doing stuff, adding graphics and streaming it out. So you would typically maybe want to do like the get everything done on the OBS side and then contribute it to something. And that's more where you get into the FFmpeg direct side.
Last question we're going to cover here in this time frame. We tend to have a lot of problems with lip sync in Zoom or other video low latency streamers. How is audio handled in low latency encoding? And do you think that these problems are the encode, decode, transmission protocol, etc.? Where is the issue?
The issue is that there are things that drop, there are things that drift, and when you're trying to do hyper low latency, you try to conceal the errors, right? And so typically that little bit of drift. Now, when it comes to like anything that's using a what's called a UVC interface, right? So you know when you like get that web presenter or that Magewell capture card, and you don't have to install drivers. There's your problem. Period. Done. Because that interface, UVC, Universal Video Capture, I think it is, which on Linux is Video for Linux 2, or AV Foundation on Mac, or Direct Show on Windows, that universal interface where it shows up as a webcam, it drifts, period, done. So if you have a direct integration with a driver like Blackmagic stuff or AJ or whatever, you can fix that. Now, if you have that, right? Let's say you're using a professional video conferencing system, you know, from Cisco or someone else, or you actually have a direct integration between what you're doing, like Blackmagic drivers or whatever, you know, an actual graphics or sorry, a capture card driver, then the protocol should be able to keep it pretty close unless something's going wrong and it's saving your butt.
We made it. We survived. We might have to go have a drink now that we've all
we need
We're just supposed to start now.
That was a lot of data. Yeah,
my brain hurts.
Wait, weren't we drinking the whole time?
Hey,
Caitlin didn't get introduced. Sorry, we should introduce Caitlin at some point.
Hi, Caitlin. Caitlin it's gotten dark. It's gotten dark.
How are you in the dark? He left you?
Yeah. No, it's kind of dark over here.
I stuck her in my neighbor's house so we could be in separate rooms, and then
got dark.
We're conserving energy before the fires come in. You know.
Andy, and Colleen, thank you so much for stopping and hanging out with us for a little while. We had a great time.
Oh, thank you, Alex. It was a lot of fun. Good to see you too, Colleen. Miss you.
And I think I got out clean, right?
You did. I think you
did.
did.
You only squared a little bit.
You did so well, Colleen.
Yes.
Now, one of these days we'll do this. We'll be sitting around on the deck out here. We're gonna get Andy to come down once. Yeah. So that'll be a good time. Although I think that we need to we may have to talk about the drinking part too. Like Andy is we got into the streaming part, but we haven't gotten to Andy is quite a connoisseur of. What are you building anything custom right now that we should know about?
I have. So during lockdown, I built a new copper still, and I haven't done any runs with it yet, but I have an intention to do. I will do more apple brandy with it, per Colleen. But my first run is almost always rum, just to see if I can get the levels right.
Nothing like calibrating the system with a little rum.
Exactly.
All right.
I mean, when you talk about the skill level when it comes to alcohol, I mean, he does the content creation and I do the content consumption, right? And then, you know, with our powers combined, we've got a full end-to-end system.
Got the encode and the decode. So
Exactly.
that's perfect. All right. Thanks, guys. It was really great having you. And thanks to everyone putting in. We didn't get to all the questions. There was a lot of them. But thank you all for coming and hanging out.
You can email
And
me if you want.
Yep. Yeah, you can get it.
Or
And
him if you want the old stuff. I love you, Andrew. I'm just trolling. I love you.
And we will we'll see you all, many of you, tomorrow morning. All right. Bye, everybody.
See you.